So good afternoon. My name is Ralph de Wargny from Intel. We're going to speak about C++, right? Who is a developer in the room? Software developer, who is using C++? Yeah, all right, so good. It's a good start. So we are going to share the presentation between Manel and myself. Manel is from a partner company of Intel called Baincore, and he is the lead consultant for parallel programming, parallel development for Intel technologies and software development, expert in C++. And myself, I'm Ralph de Wargny from Intel Software and Solutions Group. I used to be a developer. Now I'm responsible for software tools like C++ compiler and library. And we are going to give you a little overview about C++ and how to use C++ today, right, with all these processors, processing capabilities of processors. And I'm going to start for half an hour with 3 ideas of how to use C++. And then Manel is going to go into deep with parallel coding in C++. We'll look at parallel programming models, data level parallelism, thread level parallelism, and task level parallelism. So we're going to give you a well-shaped roundup about parallel coding with C++. So let's start with 3 ideas in C++, which you can use if you are developing in C++ in native code, right? So what is this? Who knows what is this? You know what it is?
Memory map.
Sorry?
Memory map.
No? More ideas? What is this picturing?
Chip.
A chip? Who said that? Okay, you can come to our booth and you get your t-shirt. So this is a processor, actually the current processor of Intel, the newest processor, 5th generation core architecture, and called Broadwell. And if you look at it, this is a starting point. If you look at it, it's not only a processor anymore. So most of the developers think the Intel processor is a processor, but it's not a processor anymore, and not only a processor anymore. So if you look at this, this is the CPU, right? CPU cores. I think this is a Core i5. And here are the 2 cores, a lot of shared memory, memory controller. But if you look at it, the processor graphics, the integrated graphics, is more than half of the die, right? So there's something we can do here. And there are many more things that if you're a C++ developer, you can do. This is just to show you the improvement from last generation to the newest generation. It was called the 4th generation. Every year we come up with a new generation. So if you see, there are 35% more transistors. So now it's 1.3 billion on a Core i7, and the 37% smaller die size. And we find that C++ developers who really are very close to the bare metal are not really using all the transistors, right? It's not easy to use all the transistors, but we find that a lot of developers not really go into deep when it's about using those transistors. And those transistors are here to help you, right? To get more performance, more functionality, to be faster in developing. So there is a lot more than you think in a C++, in a Intel processor. So just a short overview about what Intel is caring about in C++. So we have five areas we think people develop software for. The last one is not important today. It's HTML5. You don't care about that. But if you develop in C++, important are things like technical computing, right? High performance computing or technical computing in general, where you really care about performance. And it includes photo processing, signal processing, all that stuff. Then video encoding, decoding. I'm going to show you more about that later. Responsiveness. If you develop in C++, often it's because you're interested in responsiveness, right? You don't want applications that are slow to respond to the users, so it's about responsiveness. And embedded systems, of course. You're not gonna, well, maybe you're going to, but normally you do develop in native code, not in managed code on an embedded system, Internet of Things type of applications. So everywhere Intel has some kind of tool sets. I'm not going into deep about that, but who knows the Intel tool sets for software development? Parallel Studio, Intel compiler, libraries? No? All right, at least one, thank you. So let's go into the ideas. So first idea is coding in parallel. That's the main topic for this presentation. It's about parallelism. Who is already coding in parallel in the audience? Everybody? More or less? Okay. So it's about using the multi-core processors, right? There is not even one, or maybe very small processors which have only one core. So every processor has at least 2 cores, and with multi-threading, often you have 4 for you if you have only 2 cores. But there are processors with 16 cores, and we have a Xeon Phi with many more cores. So now it's really becoming more and more important, and that's about using the CPU cores, of course. So what we see at Intel in general is that technical computing is not anymore only on government research, academic type of application development. Here they develop a lot in C++ and Fortran. Well, legacy develops in Fortran. Newest applications are developed in C++. But it's also moved 20 years ago. It's already moved into commercial and industrial application. Here it's more C++ than Fortran. It's all about simulation, creating products, testing products, things like that. And then we see a lot more new uses in technical computing, and that's most of it is C++. It's big data analytics, machine learning, cloud computing, cloud analytics, and the Internet of Things, which translates also in technical computing. All right, and I showed you a processor in the beginning, which is a core processor. But if you develop in parallel, all the other processors can be also very important for you, like Intel Xeon for servers or Xeon Phi. Who heard about Xeon Phi already? Xeon Phi? You know what it is? It's a coprocessor. So you need an actual system. You plug in the coprocessor card, and you have a mini supercomputing on your workstation or on your server. Gives you about 1 teraflop of performance at the moment. And you can develop in C++ for it. So what do we see? What kind of parallelism do we see? And Manel is going to go into deep. So there are many levels of parallelism you can use in C++, right? At the very bottom, it's all about single instruction, multiple data. It's about vectorization. So current processors in Intel, and correct me if I'm wrong, we have 256 bits wide vectors. So it means you can really not only process one instruction at a time, but several instructions at a time and several data streams at a time. So this is very important to use. If you really seek performance in C++, vectorization is something you should look at. Then multi-threading, that's the more traditional parallelism, right, which are used. And then if you're in high-performance computing, if you're using clusters, if you're having server clusters, it's going to be at the node level, different servers plugged together. So one very important thing for us, whatever parallelism you're using, whatever type of system you're using, if you code in C++, if you have your C++ code, we want you to be able to run this code as soon as it's compiled on any platform. So it can be a regular PC or a workstation based on Intel Core or Xeon, a multi-core system. It can be a many-core system with Xeon Phi, this coprocessor card I told you, or a cluster or a very complex system with many servers. Your C++ code should be able to run on all these systems. This is what we call scale forward. So if you're C++ developers, whatever system your customer is using or the end user is using, we want you to be able to run this code on easily on all these systems. And so for that we have we give you several types of tools. We have programming models. Manel is going to show you. We have libraries and compilers. Who is using C++ compiler from Intel? No, but what kind of C++ compiler are you using? Microsoft. Everybody, Microsoft? Everybody. Who is on Linux? At least one, no? Oh, thank you. Who is on OS X, OS 10? Nobody? All right. Maybe you should reconsider. Okay. And for code analysis, we have also several tools. For instance, we have a tool called VTune Amplifier, which is very interesting, even if you're using Microsoft compiler. So these tools are not exclusive to Microsoft compiler. You are free to use the Microsoft compiler, but you can use, for instance, the VTune Amplifier tool in order to see how much your code is using from the cores of the core. Let's say you have 4 core systems. How do you know how much power of these cores is your code using? Do you know? Is this something you know? If you run your code, if you develop a C++ code with Microsoft, Visual Studio, etc., how do you know if you're on a 4-core system that your code is using these 4 cores? What are you using? Any answer? Sorry?
Task manager.
What? Task manager?
I'm kidding. Yeah.
No?
Well, I mean, it's not professional.
Yeah, but there's not much more, right? Maybe in the latest Visual Studio there is some more, but most of the time you don't know. You go to the task manager, you see if it's ramping up or not. But with VTune you can exactly see how much of the processor your code is using. And maybe your code is only using 1 core and that at 50%, right? And something is wrong with your code. Maybe not with your code, but with the compiler, with the setup. Something can be changed to get more performance. So this is something we at Intel cherish very much, is that you're using all this power of the processor. Why do you buy a processor for $800 and then you're not using it, right? So that's why we have a tool suite called Parallel Studio, and in there you'll find all these tools, all these helpers, all these libraries that help you use the processor efficiently. So let's take a look at video. So who is developing for video? Video application. Who is using video? Video? Okay. So we at Intel, we think the video is very important in the future. So if you look around, if you look on the internet, everything is about video, right? YouTube, and everywhere, on every website you go, there's a video starting. It can be an ad or whatever, but there's a lot of videos everywhere. And we have been thinking about this, and we have put some functionality in our integrated graphics about video. And if you look at the integrated graphics, it's kind of a GPU on the die of the processor. If you look about, let's say, 4 years ago, it was the Intel 2nd generation core. We had, this is the whole processor, right? About 25% was the integrated graphics. Then the next generation, we moved it up to 30%, 33% maybe. Then, right, this is not really good, but then it stayed at 33%, 40%, and at the current generation we are over 50%. 60% of the processor transistors are for graphics. And you see the performance, how it grew. We've been here at 2nd generation. On the 4th generation we already had 75 times increase. Now we are about 100 times increase with the 5th generation. So that's something you as a C++ developer can use. This is something that's staying here on your system, and most of the developers don't use it. You can use it for gaming, for creating images, for doing 3D world programming, but you can also use it for video. And if you look at the video, if you look around you, a lot of screens everywhere, a lot of screen sizes, from big screens, PCs, laptops, tablets, etc. So a lot of opportunities to transfer video in all sizes, to transcode video. And then there's also the opportunity of larger screens. Right? If you go to a shop now, you'll see a lot of TVs have already 4K screens, for 4 times HD screens. And if you go into expensive shops, you also will see 8K video TV sets already. So, and it's really high resolution, right? And if you have a TV like that and you have a connection to BBC somehow and you want to see a football game in 8K, there's going to be a lot of data transferred between BBC and your TV. So that's going to need a lot of power, processing power, to encode and decode the video stream. So that's one thing we are working on with the processor. Yeah, I'm showing you. And here you see HEVC. This is the format. Who heard about HEVC before? HEVC? H.265? Yeah, that's the same. So you see, HEVC is going to be in 4 years now, or 3 years, when the next World Cup is happening. A lot of people will stream the video streams for the football games in HEVC. So you better be prepared if you're a video software company. And it's not only about TV or football games, it's about more and more usage models in the video space. So it can be visual understanding, right? Analytics, scanning videos for security purposes, transcoding, if you're in the cloud, or if you're in the cloud, also transcoding, streaming videos. So more and more about that. And in the Intel processor and the integrated graphics, there are specialized functions in the hardware that help you encode and decode your video streams. And you can use these acceleration functions in C++. And so that gives you some of the solution categories you can, where you can use this in your C++ code. So it's easy for transcoding, right? Cloud transcode in the cloud, live streaming, or local transcoding on your server. Encoding, which is the most complex task in video. So for gaming, visualization, whatever, a lot of stuff. And of course, decoding, which is the most common function in video. And so if you look at our processors, these functionalities are available in the core processors, in Xeon, E3, and also in some Atom versions. And so what's in there? So there is a hardware accelerator for video encoding and decoding. So you can, some of the video codecs can be decoded and encoded via acceleration. So at the current state, you can encode with hardware acceleration the H.264, but not H.265. So this is software-based acceleration. But hardware-based acceleration can be done until H.264. So you can do video processing, a mix between GPU and CPU if you want, or you can also do some 3D graphics with OpenGL and DirectX. So who is doing graphics programming here? Okay. All right, so we have a product called Media Server Studio, which gives you all that stuff to be able to use this video acceleration to hardware acceleration. Have a look. It's called Media Server Studio. You can download it for free, the lowest version. But if you're interested in video programming, just download it and try it out. And here is one example what you can achieve with this video acceleration. So let's say you do cloud transcoding, and you want to transcode 3,000 concurrent HD transcodes, 3,000 video streams at the same time. You want to transcode them. And it's had been developed in C++, of course. The current state is you are using graphic cards on 10 racks of graphic cards. All right? It consumes a lot of energy, a lot of space. And if you move this to the Xeon E3 V3, which has integrated graphics, you can do a 5-to-1 consolidation. And that means you can use 84% less energy, right? So using C++ with enabling the hardware can really, really have actual benefits, right? So 84% energy reduction, 56% hardware cost reduction, and 80% floor space reduction. So I think that's a very good application of C++. Third idea, create new man-machine interactions. So who did hear about RealSense? RealSense? You know Kinect, Microsoft? Everybody knows Microsoft. Kinect? Okay, but Kinect works only on the Xbox, no? Or does it work on a PC?
It works on a PC too.
On a PC too?
Potentially.
All right. But it requires an external thing, right, to detect, okay, sensor. Yes, so we have been thinking about that at Intel as well. And so we have been thinking about interaction with computing devices, you know, all the story with, text only, then Windows, then touch. What's next? It's Kinect, for those who are from Windows, Microsoft. But we also have our ideas about that. And we want to change the way developers and users can interact with the machine. And we have thought about the next generation. So what can we do? We want to have an interaction which is more natural, more intuitive and more immersive. So that means we want to go into speech recognition mixed with facial tracking, close range finger tracking, close range gesture tracking. That's more the Kinect, right? And augmented reality. And we have been working in 2013 with a company called Creative, which developed with us a 3D camera, an external camera. It was a USB 2.0 camera with 720 lines HD. And we continue to work on it because an external camera is not the solution, right? Everybody on his laptop or tablet has a camera, 2D camera, and we think it's worth to have a 3D camera. So we developed our own 3D camera. It's really a very thin camera. It's like 2 millimeters thin. It has a laser on board, several cameras, and it's able to do HD, 1080 HD. It's very thin. It's very performing. And it's a depth camera, so it can look into depth, and it's not consuming a lot of energy. And this year, a lot of OEMs, so computer manufacturers, will integrate this camera into their laptops already. So what can you do as a C++ developers? Because you're not a consumer, so you want to use these camera in C++. So we have developed a thing called the Intel RealSense SDK, which helps you to touch several modalities, like the one I said in the beginning, hand-finger tracking, gesture recognition, facial analysis, background subtraction. I'm going to show you what that is. User-facing speech recognition. It works on all processors. It works on Windows. It's good news, right? It supports C++, but also C# and Java. Not for everything Java, but C# and C++ are fully supported. And Visual Studio, the latest version as well, don't worry. And other development tools are supported as well. And if you look at the difference, if you look at advanced finger tracking and hand tracking, with the external camera, with the first RealSense SDK, you could detect and track the fingertips, right? And how do you call this? The palm, and the forearm. But now you can really track all the bones. So there's a bone tracking capabilities and the joints. So you can really see if the fingers are moving. And this is something you can touch with the RealSense SDK. Facial analysis, also something that we worked on. So now it's much greater accuracy, many more points in the face you can track to do whatever you think in your C++ code. detection of face, this is the more easy one, right? And the points, then also the pose. So is it facing or looking left or looking right, looking down, looking up? You can track all that. Okay, we talked about that, sorry. Other thing, you can do some augmented reality. So you can track objects, 2D objects in 2013 version, but now you can also track 3D objects, right? It will detect if an object is 3D. If you move the object, if you turn it, it will track it. It will follow the object. Another application of augmented reality is background subtraction. So you can detect the face, you can detect the hand. That means you can remove the background, right? An application is, we did a test with Skype. So you can do a specific version of Skype and remove the background. So it looks like you are for half an hour with 3 ideas of how to use C++. And then Manel is going to go into deep with parallel coding in C++. We'll look at parallel programming models, data level parallelism, thread level parallelism, and task level parallelism. So it's going to give you a well-shaped roundup about parallel coding with C++. So let's start with 3 ideas in C++, which you can use if you are developing in C++ in native code, right? So good afternoon. My name is Ralph de Wargny from Intel. We're going to speak about C++, right? Who is a developer in the room? Software developer, who is using C++? Oh, yeah, all right, so good. It's a good start. So we are going to share the presentation between Manel and myself. Manel is from a partner company of Intel called Baincore, and he is the lead consultant for parallel programming, parallel development for Intel technology. What is this? Who knows what is this? You know what it is?
Memory map.
Sorry?
Memory map.
No?
No.
More ideas? What is this picturing?
Chip.
A chip? Who said that? Okay, you can come to our booth and you get your t-shirt. So this is a processor, actually the current processor of Intel, the newest processor, 5th generation core architecture, and called Broadwell. And if you look at it, this is a starting point. If you look at it, it's not only a processor anymore. So most of the developers think the Intel processor is a processor, but it's not a processor anymore, and not only a processor anymore. So if you look at this is the CPU, right? CPU cores. I think this is a Core i5. And here are the 2 cores, a lot of shared memory, memory controller. But if you look at it, the processor graphics, the integrated graphics, is more than half of the die, right? So there's something we can do here. And there are many more things that if you're a C++ developer, you can do. And software development expert in C++. And myself, I'm Ralph de Wargny from Intel Software and Solutions Group. I used to be a developer. Now I'm responsible for software tools like C++ compiler and library. And we're going to give you a little overview about C++ and how to use C++ today, right, with all these processing capabilities of processors. And I'm going to start